Hello, welcome to another class with Physics Anchor. Today we'll be solving some past questions from JAMB, past questions for the benefit of those students that will be writing JAMB. And today the questions we have are extracted from the topic simple harmonic motion. I have three questions on the board. Let's get started. The question number one. A particle of mass 10 raised power minus 2 kilogram is fixed to the tip of a fan blade which rotates with angular velocity of 100 rad per second. If the radius of the blade is 0.2 meter, the centripetal force is dash. So in other words, they want us to calculate the centripetal force. So in our culture, let's look at what we have been given to work with. We have been given the mass, which is 10 raised power minus 2 kilogram in SI units, so we don't have to convert that. And we have been given the radius, the angular velocity. We have angular velocity as 100 rad per second. And we have been given the radius. The radius is 0.2 meter, and then they want us to calculate the centripetal force. Okay, so the centripetal force that they want us to calculate is calculated with the formula mv square over r. So this is the formula for centripetal force. I hope you remember that. So you have to work with this formula. So I'm just writing this force, subscript C, so that you will see that I'm calculating what centripetal force. So do I have everything ready? The only thing I do not have is V. This one is linear velocity, but we do remember that our linear velocity and angular velocity are related with this formula. That's linear velocity equals angular velocity multiplied by radius. So let's use that to actually let's introduce that to get our V first, and then we can come back to find our centripetal force. So we have V equals our angular velocity, which is what, 100, okay, multiplied by our radius 0.2. That will give me 100 times 2 over 10, okay, and that will give me 20 meter per second. So now that I have my linear velocity, so I can calculate this centripetal force now with the formula mv square over r. That will be mass, which is 10 raised power minus 2 times v square. My v square is 20 squared, and then my r is 0.2. So I can say that I have 1 over 100, that is 10 raised power minus 2 will give me 1 over 100, okay, times 400, all divided by this line divided by 2 over 10. Okay, so 0 cancel 100, that would be 4 over 1 times, let me invert this, that would be 10 over 2, 2 here 1, 2 here 2, that would be 20. 20 what? Since we are calculating what? Force, that's 20 Newton. Okay, you can use your calculator if you have your calculator with you. So I'm just working with that calculator. So pardon me. So let's check the options. Option A, no. Option B, 20 Newton. Okay, so our answer is 20 Newton. So option B is the correct option. I hope you understand this. So the only thing in this analysis is that what you must remember, that your centripetal force is mv square over r. Once you get that right and you have this relationship, you can always find your correct answer. So let's move to number 2, question number 2. Just a few seconds to rub off this. Okay, let's move to question number 2. A particle in circular motion performs 30 oscillations in 6 seconds. Its angular velocity is dash. So in this question, they want us to calculate the angular velocity. But the good thing is that first scan through your options given. You can see that what they are not substituting value for pi. So pi is still in pi. So our answer will be in pi. So we know what we are working with already. So let's state what we have here. I can see that it performs 30 oscillations. So our number of oscillations, which is n, is equals to 30. And the in 6 seconds, that's t equals to what? 6 seconds. That is the time taken. So they want us to calculate the angular, okay, velocity. So this is what they want us to calculate, angular velocity. We know that what? Angular velocity can be calculated as what? 2 pi f. That's the frequency, or you say w equals to 2 pi over t. This is the period. Anyone you want to use is fine, okay? Because your f is n over t, while your period is what? T over what? N. So anyone you want to use is fine. So let me just use 2 pi, okay? F, that's 2 pi f, okay? If I use 2 pi f, I'm going to be having 2 pi times, okay, my f will be n over t. So my n is 30, and my what? My t is what? 6. Okay, this is what I'm doing. That's 30 over 6, which will give me 5 Hertz. Or you do 6 over 30, that will give you 1 over 5 seconds. So anyone you want to use is fine. You always get your answer. So that will be W equals to 2 pi. Okay, so 2, our t is 6. So let's substitute the value of t also, which is what? 6. So that will be 2 pi times 5, which is our what? Frequency. So that's what? W equals to 2 times 5, that will be 10. 10 what? 10 pi. And the unit of angular velocity is what? Rad per seconds. Okay. So that's fine. That's what will be our answer. Even if you use this also, it's the same thing. W equals to 2 pi over t. So you can say W equals to 2 pi divided by what? T equals 2t divided by, what is your t? Your t is what? 1 over 5. Put this over 1. 2 pi over 1 times 5 over 1. That will still give you 10 pi rad per seconds. So the same thing. Okay, the formula is just that we are using frequency and then we are using period. So let's check our option. That's 10 pi rad per second. So that is option A. Option A is the correct what? Answer. So I hope you are coping with this. So it's just to refresh your mind on simple harmonic motion. It's a very important topic that you must not joke with before the day of your exam. So let's move to number 3. Question number 3. Okay. If in a simple pendulum experiment, the length of the inextensible string is increased by a factor of 4. Please note that. Increased by a factor of 4. Its period is increased by a factor of dash. In other words, in this question, now we have that the length, okay, of this pendulum is increased by a factor of 4. Now, let's look at the basic thing that we know about simple pendulum. The basic thing is that we know that the period is directly proportional to the root of the length of the simple pendulum. So, period is directly proportional to the square root of the length of the simple pendulum. So, from here, of course, we are not going to do any proving here because this is just the solution to past question. But I will just give you the basic thing that you're supposed to know. If we are to compare the period of two simple pendulum with what? Their length. So we have the relationship that what? T1 over T2 equals to root L1 over root L2. And this, okay, if we take the square of both sides, okay, if we take the square of both sides, if we take the square of both sides, this will give us the relationship that what? T1 squared over T2 squared equals, okay, this root will remove, that's L1 over L2. So this is what you need. You need to actually have this at the back of you when it comes to what comparing the periods and the lengths of two different or simple pendulum. Okay, so it's very important that you have this relationship at the back of your mind. So now let's check the question now. The length is increased by a factor of 4. So in other words, it means that our L2 equals to 4 of L1. Okay, L1 is the original length here now. So it's now increased by a factor of 4. They did not say that what plus 4. A factor of, when you hear of simply means multiplication. Okay, so factor of 4. So 4 of L1, okay, will give us 4L1. So in this case now, our L2 is now 4L1. So we can go back to this formula by saying that T1 squared over T2 squared equals to L1. Now instead of writing L2, we just write 4L1, okay? So L1 cancel L1 here. This one will give me 1 over 4, okay? So I will be having T1 squared over T2 squared equals to 1 over 4. So if we cross multiply this, okay, 4 times this and 1 times this, my T2 squared will be equals to 4T1 squared, okay? So let's take the root of both sides. So if we take the square root of both sides, I'm going to be having T2 equals to root 4T1 squared. And that will give me, square root of 4 will give me 2. Square root of T1 squared will give me what? T1. Therefore, I can say that what? T2 equals 2T1. Or I write it as what? 2 of T1. In other words, the period, while the length is increased by a factor of 4, the period has been increased by a factor of what? 2. So since it is what? A factor of 2, my answer will be 2. So let's check the option. So not A, not B, not C, not D. Okay, E. E, a factor of what? 2. So that is 2, and that is the final answer. I hope you have gained something from the solution we have just done in the class today. It's very important that you refresh your mind in this topic, simple harmonic motion, before the day of your exam. If you have any questions in this area or any other question in physics that bothers you, please kindly drop the question for me in the comment section below. Share out this video with other students around you. Subscribe if you have not done so. Hit the notification bell so that you can always be informed anytime I drop a new video. I wish you all the very best in your examination. Bye for now.